Imagine for a moment receiving a postcard from the edge of forever, not with pictures but with a code that simply shouldn't exist. That's the reality scientists are grappling with right now, thanks to Voyager 1. This legendary probe, drifting an unimaginable 15 billion miles away, a lonely sentinel in the interstellar void, has sent back data containing, well, something that defies explanation. Buried within its latest transmission, potentially one of its last before its long silence, was a structured pattern of neutrinos. Pause and let that sink in. Neutrinos. These aren't just any particles, they're the universe's ghosts. And Voyager 1. It has absolutely no way to see them. This isn't just unusual, it's like finding a detailed blueprint for a skyscraper drawn by someone who's been blind since birth and never held a pencil. Could this be a final, unexpected gift from our aging explorer, a clue to unlocking cosmic secrets we never dreamed of? Or is it something else, something that makes the hair on the back of your neck stand up? What do you think could be happening out there, 15 billion miles away? Let's dive into one of the most baffling scientific mysteries of our time. Imagine the scene. Scientists at NASA's Jet Propulsion Laboratory, JPL, and collaborating researchers, perhaps sipping lukewarm coffee, expecting another routine data download from Voyager 1. For years, this steadfast probe has been our eyes and ears in the vast, empty expanse beyond our solar system's protective bubble, the heliosphere. It's been diligently measuring interstellar plasma, charting the flow of cosmic rays, valuable data, certainly, but data that fits within the known rules of physics. But this time was different. Amidst the expected readings, the familiar hum of data from the edge of interstellar space, something else emerged. Not a random burst of static, not a glitchy sensor reading, but a pattern. A clear, repeating, mathematically precise sequence. When the initial analysis came back, eyebrows must have shot towards hairlines. The pattern perfectly mirrored the distinct, flavor-changing behavior, the oscillations of neutrinos. Now let's truly grasp why this is so utterly mind-bending. Neutrinos are often called ghost particles, and for good reason. They are born in the heart of nuclear reactions, inside stars like our Sun, in exploding supernovae, in reactors here on Earth, but they barely interact with anything. Right now, trillions upon trillions of neutrinos are streaming through your body, through this device, through the entire planet as if it were empty space. They don't carry an electric charge. Their mass is almost zero, and they only weakly feel the aptly named weak nuclear force and gravity. To actually detect these elusive particles, we have to build colossal instruments. Think of the Ice Cube Neutrino Observatory buried deep within a cubic kilometer of pristine Antarctic ice, using the ice itself as a detection medium. Or Super Kamiokande in Japan, a gigantic tank holding 50,000 tons of ultra-pure water, lined with thousands of sensitive light detectors, hidden nearly a mile underground to shield it from confusing background radiation. These are monumental feats of engineering, costing billions, designed solely to catch the faintest whispers of neutrino interactions. And Voyager 1, launched in 1977, it's a marvel of its era, equipped with instruments brilliant for studying planets, magnetic fields, and charged particles. But a neutrino detector? Absolutely not. It would have been technologically impossible back then, and even now, strapping a Super Kamiokande onto a space probe is pure science fiction. Voyager simply does not possess the physical capability to detect neutrinos directly. It's like trying to hear a whisper in a hurricane, using only your eyes. Yet the signal was there, clear as day in the data stream, a structured sequence mimicking neutrino oscillations. More disturbingly, when scientists tried to trace the origin, it didn't align with the Sun, our primary local source of neutrinos. It didn't match patterns expected from known cosmic ray interactions or distant blazars or supernovae. The origin seemed elsewhere, unknown. The first logical reaction: it must be a mistake. a glitch in the aging hardware, nearly half a century old and bathed in the harsh radiation of interstellar space. Interference from some powerful cosmic event, perhaps a gamma ray burst distorting the signal, or maybe even stray radio waves from Earth somehow corrupting the transmission across 15 billion miles. But as the checks began, these easy explanations started to crumble. The scientific community doesn't jump to sensational conclusions. Rigor is paramount. NASA's JPL, working closely with particle physics experts at CERN, the European Organization for Nuclear Research, home of the Large Hadron Collider, began a meticulous process of elimination. Could a solar flare have caused some weird plasma interaction that mimicked a neutrino signal in Voyager's other instruments? They checked the timing against solar activity. No correlation. Could powerful cosmic rays hitting the spacecraft have generated a secondary cascade that produced this pattern? The energy signatures didn't match, and the pattern's regularity was unlike typical cosmic ray noise. Could it be terrestrial interference? Highly unlikely, given the specific frequencies Voyager uses, the Deep Space Network's sophisticated filtering, and again, the unique structure of the signal itself. It wasn't radio noise. It was something encoded within the data related to the interstellar medium Voyager was sampling. This is where the investigation took a fascinating turn. Powered by modern technology Voyager's creators could only have dreamed of: artificial intelligence. Specialized deep learning algorithms, initially developed for complex tasks like searching for faint, potentially artificial radio signals in the SETI Search for Extraterrestrial Intelligence project, were turned loose on the Voyager data. These AI systems are incredibly adept at identifying subtle, complex patterns hidden within vast datasets, patterns that might elude human analysts. The AI didn't just confirm the pattern was real and not random noise. It went further. It deciphered an internal logic within the sequence. The pattern wasn't just a simple ABAB repetition. It followed complex mathematical rules that precisely matched the quantum mechanical probabilities governing how neutrinos oscillate or change flavor. From electron neutrino to muon neutrino to tau neutrino, as they travel through space. Imagine finding a message written not just in a repeating alphabet, but following the grammatical rules of a complex language you didn't even know existed. Dr. Miguel Fuentes, a fictional astrophysicist perhaps working at the SETI Institute, might have commented something like this: "We spend our lives sifting through cosmic static, hopping for a whisper of something non-random. We've seen signals from pulsars, quasars, fast radio bursts, all fascinating natural phenomena with their own signatures. This is different. It doesn't fit any known astrophysical source profile. The structure, the adherence to neutrino oscillation physics, but without a detectable source or mechanism on Voyager. It's profoundly puzzling." Then came the discovery that truly ignited the debate, pushing it towards the fringes of accepted science. Embedded within the complex oscillations, the AI analysis highlighted segments that seemed to follow sequences related to prime numbers and specific geometric ratios. Why is this significant? Prime numbers, numbers divisible only by 1 and themselves, like 2, 3, 5, 7, 11, are considered by many scientists to be a potential hallmark of intelligence. They are fundamental building blocks of mathematics, unlikely to occur in such structured sequences purely by random natural processes. For decades, theoretical proposals for interstellar communication have suggested using primes as a universal mathematical concept to signal artificiality. Professor Li Chung, perhaps a leading cosmologist pondering the implications, might raise a cautious but profound question. Forget SETI for a moment. Let's consider the physics. If Voyager, through some unknown mechanism, perhaps interacting with a field or particle we don't yet understand, somehow recorded or transduced this neutrino behavior, what does that imply? Could interstellar space itself contain phenomena that can impress such structured information onto passing probes? Or, pushing further, if something deliberately used neutrinos, perhaps these hypothetical sterile neutrinos, to encode a message using mathematical principles like primes, knowing they would pierce through cosmic dust and gas? Could Voyager have accidentally stumbled upon it? We are deep into speculation here, but the data resists easy explanation. The scientific world found itself split. Some clung to the hope of a novel, natural explanation, a new fundamental force interacting with Voyager's aging plutonium power source, perhaps, or an undiscovered property of interstellar plasma interacting with high-energy particles. Others, looking at the mathematical structure, couldn't entirely dismiss the unsettling possibility of something deliberate, even if the idea of an alien neutrino message seems like pure science fiction. But almost everyone agreed on one thing. This wasn't a simple instrument malfunction. Voyager 1, in its twilight years, had sent back a genuine enigma, sparking one of the most intense scientific debates in decades. With straightforward explanations failing, scientists are forced to venture into the theoretical wilderness. The possibilities range from revolutionary physics to phenomena straight out of science fiction, each carrying staggering implications. Theory 1. Rewriting the rules, a glimpse of new physics. Perhaps the most exciting possibility, from a physicist's perspective, is that Voyager 1 hasn't intercepted anything external, but has instead experienced something new about the fundamental nature of reality itself. This brings us to the concept of sterile neutrinos. Our current standard model of particle physics describes three types, or flavors, of neutrinos: electron, muon, and tau. We know they have tiny masses and can oscillate or change between these flavors as they fly through space. But for decades, some puzzling experimental results and theoretical considerations have hinted at the existence of a fourth type, the sterile neutrino. Unlike its siblings, the sterile neutrino wouldn't interact via the weak nuclear force or the electromagnetic or strong forces. It would only interact through gravity, making it even more ghost-like and virtually impossible to detect directly with current technology. Why are physicists interested? Sterile neutrinos, if they exist with the right properties, could be a major component of dark matter, the mysterious, invisible substance that makes up about 85% of the matter in the universe and holds galaxies together. Finding direct evidence of sterile neutrinos would be a Nobel Prize-winning discovery, confirming physics beyond the standard model and potentially solving the dark matter puzzle. Could Voyager 1, perhaps through an unknown interaction between its decaying plutonium-238 power source, its radioisotope thermoelectric generator, or RTG, and the surrounding interstellar medium, or even through some quantum tunneling effect amplified over its long journey, have somehow become sensitive to these sterile neutrinos? Could the structured pattern be the signature of sterile neutrinos oscillating, or perhaps interacting with regular neutrinos in a way we've never observed? If this is true, it would mean Voyager 1, an artifact of 1970s technology, accidentally achieved what multi-billion-dollar, state-of-the-art laboratories on Earth have failed to do: find evidence for sterile neutrinos. It would revolutionize particle physics and cosmology. But the giant, flashing question mark remains. How? What physical mechanism, completely unknown to us, could allow an old probe with simple particle detectors to pick up this signature? It requires a leap in understanding particle interactions in the unique environment of deep interstellar space. Theory 2. A signal from the deep, natural or artificial. Another line of thought suggests Voyager 1 didn't generate the signal internally, but rather intercepted it. The signal originated out there, in the vast darkness between the stars. But from what? One possibility is an unknown cosmic phenomenon. We are still discovering new types of celestial events. Could extremely powerful, exotic objects like magnetars, neutron stars with stupendously strong magnetic fields, or specific types of pulsars, under certain conditions, generate focused beams of neutrinos with complex, repeating patterns? Perhaps interactions within dense accretion disks around black holes, or even more exotic hypothetical objects like quark stars, could be responsible. If so, Voyager 1 might have simply drifted through the path of such a beam, a previously unknown type of natural cosmic broadcast. This would still be a major astrophysical discovery, revealing new high-energy processes in the universe. But then there's the other, far more controversial interpretation, fueled by the signal's mathematical structure, the hints of prime numbers and geometric ratios. What if it's artificial? This is deep into speculative territory, the realm of SETI. But consider the logic. If an advanced extraterrestrial civilization wanted to create a beacon, a message designed to travel vast interstellar distances with minimal interference, neutrinos would be an almost perfect medium. They slice through gas clouds, dust lanes, planetary bodies, even stars, largely unimpeded. Unlike radio waves, they aren't easily scattered or absorbed. Could the structured pattern be a deliberate message, encoded using the universal language of mathematics? Could the oscillations themselves form the basis of a complex signal, with the prime number sequences acting as a flag to indicate intelligence? If this were true, Voyager 1 wouldn't just be a probe. It would have accidentally become humanity's first receiver for an interstellar neutrino communication channel we didn't even know existed. Of course, there is zero concrete evidence to support this interpretation yet. It remains pure speculation. But the unusual structure of the signal keeps the question nagging at the edges of the scientific discussion. It highlights a fascinating point. How would we recognize an alien signal if it used physics or methods completely outside our current technological or theoretical framework? Theory 3. The ghost in the machine malfunctioned too. We must always return to the simplest explanation. Could it still be instrument failure or some internal anomaly, just a really, really weird one? Voyager 1 is almost 50 years old. Its components have endured decades of hard vacuum, temperature extremes, and radiation bombardment. Things are bound to get strange. However, as Dr. Ethan Patel, perhaps a fictional former NASA engineer who worked on similar deep space missions, might argue, glitches happen. We see sensor noise, data corruption, component failures. They tend to look random, chaotic, or like a complete breakdown. They don't typically spontaneously organize themselves into complex, mathematically precise patterns, mimicking the quantum behavior of particles the spacecraft can't even detect. If this is a malfunction, it's a malfunction unlike any we've ever conceived of. It's mimicking physics it shouldn't know about. Why this specific pattern, neutrino oscillations? Why the mathematical order instead of random gibberish? If it's an internal electrical issue, why does it look like a signal governed by fundamental constants of nature? These questions make the simple glitch hypothesis unsatisfying for many researchers. This leads to a subtle variation. Perhaps it's not a malfunction in the traditional sense, but an unknown interaction. Could Voyager 1 have passed through a region of interstellar space with peculiar properties? Maybe a filament of dark matter, a strange plasma field, or something utterly unforeseen that interacted with its systems, particularly its RTG or plasma wave instrument, in such a way that its transmitted signal was altered, imprinted with this neutrino-like pattern. In this scenario, Voyager didn't detect neutrinos, but something else made its signal look like it did. This is still speculative physics, but it avoids needing Voyager to have impossible detectors. Right now, there are no definitive answers, only tantalizing, frustrating, and exhilarating theories. Voyager 1, our silent ambassador sailing into the cosmic ocean, has tossed back a message in a bottle containing a riddle that challenges the very foundations of our knowledge. To fully appreciate the weight of this final mystery, we need to remember the incredible journey that brought Voyager 1 to this point. Its story isn't just about data points. It's about human ambition, exploration, and our enduring quest to understand our place in the cosmos. Launched on September 5, 1977, just weeks after its twin, Voyager 2, its primary mission was a grand tour of the outer solar system, taking advantage of a rare planetary alignment. Voyager 1 was our robotic eyes, giving humanity its first truly intimate portraits of Jupiter and Saturn. We saw the churning, violent beauty of Jupiter's great red spot, discovered active volcanoes on its moon Io spewing sulfur hundreds of miles high, the first volcanic activity seen beyond Earth. Then came Saturn. Voyager 1 flew breathtakingly close, revealing the intricate, dancing structures within its majestic rings, finding shepherd moons sculpting their edges. It gave us our first detailed look at Titan, Saturn's largest moon, peering through its thick, nitrogen-rich atmosphere, hinting at a world with liquid methane rivers and lakes, a tantalizing analog to early Earth. Its planetary encounters complete, Voyager 1's mission was far from over. Its trajectory flung it upward, out of the plane of the solar system towards the stars. In 1990, at the request of astronomer Carl Sagan, NASA turned Voyager 1's cameras back towards home one last time. From a distance of nearly 4 billion miles, it captured the iconic pale blue dot image. Earth, our home, reduced to less than a single pixel, a tiny mote of dust suspended in a sunbeam. It was a humbling perspective shift, reminding us of our cosmic insignificance and, paradoxically, the preciousness of our world. For years, it sailed onward, crossing milestone after milestone. Then, in August 2012, history was made. Voyager 1 passed through the heliopause, the boundary where the solar wind's influence gives way to the interstellar medium. It became the first human-made object ever to enter interstellar space, the vast, unexplored territory between the stars. Scientists knew its power levels were dropping. The plutonium in its RTG decays steadily, providing less and less electricity each year. Instruments would eventually have to be shut down. Communication would become fainter, harder to detect. Eventually, inevitably, it would fall silent. But Voyager 1 defied expectations. It kept talking, kept sending back invaluable data about the conditions outside our solar system. The density of interstellar plasma, the intensity of galactic cosmic rays, the direction of the interstellar magnetic field. It was rewriting textbooks even as its power waned. And now this. As Voyager 1 approaches its final years, perhaps its final months of transmission, it sends this signal. The routine data stream, the expected farewell whispers from the interstellar medium, suddenly contained this impossible ghost pattern, the structured neutrino sequence. The initial reaction at JPL and CERN wasn't celebration. It was deep concern and confusion. Could the data be corrupted? Was the aging deep space network antenna system introducing artifacts? They ran diagnostics, cross-referenced with other observatories, performed every sanity check imaginable. The pattern persisted. It wasn't noise. It wasn't an error in transmission or reception. It was embedded in the source data from Voyager itself. The AI analysis confirmed its structure, its adherence to neutrino physics, its mathematical complexity. If it was a malfunction, it was the most bizarrely specific and physics-mimicking malfunction in the history of engineering. If it was interference, it was unlike any known natural or artificial source. This raises the ultimate chilling questions. What phenomenon in the interstellar void could imprint such a specific, complex pattern onto Voyager's simple instruments or its transmitted signal? Did our probe accidentally brush against something truly unknown out there? Did it, in its final act, intercept a form of communication or a natural phenomenon so alien that we lack the framework to comprehend it? Or has Voyager 1, through some fluke of its aging systems interacting with the exotic environment of interstellar space, simply generated the most profound and misleading glitch in scientific history? Right now, nobody knows. But Voyager 1, the little probe that could, the farthest object touched by human hands, has gifted us one last, magnificent mystery before its eternal silence begins. A puzzle from 15 billion miles away that could change everything. This discovery isn't just a curiosity, it's a ticking clock. Voyager 1's RTG is producing significantly less power than it did at launch. NASA engineers have been performing miracles to keep its essential systems running, shutting down heaters and non-critical instruments. But the end is inevitable. Within the next few years, perhaps sooner, there simply won't be enough power to operate the science instruments or the transmitter. Voyager 1 will fall silent forever, continuing its journey through the Milky Way as a cold, dark relic of human ambition. This reality injects a desperate urgency into the investigation. If this neutrino pattern is a real phenomenon, we need to understand it now, while Voyager might still offer clues. The first order of business is a deep dive into the archives. Scientists are now meticulously reanalyzing all historical data transmitted by Voyager 1 since it entered interstellar space in 2012. Could this pattern have appeared before, perhaps fainter or more intermittently, and been dismissed as noise? Finding earlier instances would be crucial evidence against it being a one-off glitch related to recent degradation. Simultaneously, NASA is intensely scrutinizing data from Voyager 2. Though traveling in a different direction and currently slightly less distant, Voyager 2 is also in interstellar space and possesses similar, though not identical, instrumentation. Has Voyager 2 ever detected anything remotely resembling this pattern? If it has, that would be a bombshell, strong evidence pointing towards an external, widespread phenomenon rather than a unique Voyager 1 issue. If it hasn't, it deepens the mystery around Voyager 1 specifically. Since Voyager 1 itself cannot directly confirm a neutrino source, scientists are turning to our planet's most powerful neutrino ears. The giant ice cube detector in Antarctica and the Super Kamiokande facility in Japan, along with other neutrino observatories, are being tasked with an unprecedented challenge. Can they detect a neutrino signal coming from the general direction of Voyager 1's region of space, or perhaps from a potential source along its past trajectory that matches the specific oscillation pattern reported? This is incredibly difficult. Neutrino astronomy is notoriously hard. Pinning down faint sources is a major challenge. But if, and it's a huge if, one of these ground-based observatories were to independently detect the same structured neutrino oscillation pattern coming from deep space, it would be monumental. It would confirm the signal is real, astrophysical in origin, or perhaps even artificial, and not just an artifact of Voyager's systems. Dr. Lion Zio, perhaps a fictional physicist on the Ice Cube team, might say, "We're essentially looking for a specific neutrino song that Voyager heard. If we hear the same song coming from the cosmos, it changes the game entirely. It could mean new neutrino sources, maybe interactions linked to dark matter, or something completely unexpected. We are listening intently." This puzzle is bigger than any single agency. NASA, CERN, the European Space Agency, ESA, and numerous universities and research institutes worldwide are collaborating. Astrophysicists, particle physicists, AI experts, plasma scientists, and even SETI researchers are pooling their expertise, running simulations, debating theories. It's a testament to the scientific spirit facing a profound unknown together. But the pressure is immense. Every day, Voyager 1 grows weaker. Every transmission could potentially be its last containing useful scientific data. If the answers are locked within Voyager's future signals, the window to receive them is rapidly closing. Once it goes silent, we lose our only direct link to this specific anomaly. The mystery might remain unsolved forever, a haunting, what if, whispered from the edge of interstellar space. Will we see this signal again? Scientists are debating the possibilities. A one-time anomaly, caused by Voyager passing through a unique, transient region or experiencing a unique, unrepeatable internal event. A repeating cosmic signal, generated by a stable, undiscovered natural source, like a weird pulsar, that we might detect again if we know where and how to look. An artificial transmission, a possibility fraught with speculation, but one that the signal's structure forces us to at least consider, however remotely. If Voyager 1 detected something real and external, the implications are staggering: new physics, new cosmic events, perhaps even contact, however unintentional. If it was an internal quirk, it's a lesson in the complexities of aging technology in extreme environments. Right now, all we can do is search, analyze, theorize, and wait, hopping for another clue before the silence falls. Voyager 1, our species' farthest emissary, stands as a testament to human curiosity and ingenuity. For nearly half a century, it has journeyed into the unknown, fundamentally changing our view of the solar system and venturing into the vast ocean between the stars. Now, in what might be its final act, it hasn't provided a neat conclusion, but rather a profound question mark. The discovery of a structured neutrino pattern, something seemingly impossible for Voyager to detect, embedded in its fatting transmissions, has left the scientific world reeling. Is it a glitch of unprecedented strangeness, a cosmic coincidence of astronomical odds, or the first hint of something far greater, a new force of nature, evidence for elusive sterile neutrinos, a previously unknown astrophysical phenomenon, or even, however unlikely, a whisper from intelligence beyond our own? The truth is, we don't know, and we may never know for certain. Voyager 1's power is fading. Soon, its voice will be lost to the cosmic static. If we don't decipher this riddle before then, it could remain one of the greatest unsolved mysteries in the history of exploration, a final, baffling enigma from the edge of forever. But perhaps that is Voyager's ultimate lesson. The universe is not just stranger than we imagine, it may be stranger than we can imagine. This probe, built by human hands nearly 50 years ago, has pushed the boundaries of our knowledge time and time again. In its final message, it reminds us that there is still so much we don't understand. It challenges us to keep questioning, keep exploring, keep listening to the whispers from the void. Even if this specific signal turns out to be an incredibly complex malfunction, the process of investigating it pushes our science forward. It forces us to re-examine our assumptions, refine our detection methods, and consider possibilities we might have previously dismissed. True scientific progress often comes not from confirming what we know, but from confronting what we don't. In our own lives, how often do we encounter anomalies, things that don't quite fit our expectations or understanding? Do we dismiss them as glitches, or do we allow ourselves to be curious? Voyager's story is a powerful reminder of the value of perseverance, nearly 50 years and still going. The importance of looking closely at the unexpected, and the profound beauty of embracing mystery. Sometimes, the most valuable discoveries lie hidden in the data we initially overlook or can't explain. Maybe the key isn't always having the answers, but learning to ask better questions and having the courage to face the vastness of our own ignorance. What do you ultimately think is behind Voyager 1's strange signal? A breathtaking discovery waiting to be confirmed? An incredibly complex technological ghost? Or something else entirely? Share your thoughts and theories in the comments below. Let's explore this mystery together. Thank you for joining us on this journey to the edge of understanding. We wish you good health, clear skies, and a continued sense of wonder about the incredible universe we inhabit. And if you don't want to miss the next potential breakthrough or cosmic mystery, make sure to hit subscribe and turn on notifications. We'll keep bringing you the latest from the frontiers of space and science.